Okay, so we're going to look at various types of collisions. The first type of collision we're going to look at is the elastic collision. So how do we know if a collision is elastic? Well, one of the things we know is that after the collision, the objects will be separate. Okay, they're not going to be connected, they're not going to be stuck together, they'll separate. Okay, and not only will they be not stuck together, they'll separate, they will retain their original shape, so they're going to look the same as they did before the collision. Okay? An example would be if you hit two pool balls together, okay? They're going to look the same before the collision as they do after the collision. Okay? Similarly with croquet balls, okay? Things like that. They're not going to end up changing their shape. So what happens? What do we know? Well, if there's an elastic collision, then kinetic energy is conserved. Okay, so the total kinetic energy beforehand is equal to the kinetic energy afterwards. Also, momentum is conserved. Okay, now we talk about elastic collisions. We say that if they separate and they retain their shape, then they are elastic. Okay, and kinetic energy is conserved. But that's not 100% true because in reality, no collision is completely elastic. Okay. Why do I say this? Well, because when these two billiard balls hit, there's going to be sound. So some of this kinetic energy is going to be transformed into sound, but it's going to be such a small amount of the original that it's not going to affect our calculations. Okay? The second type of collision is an inelastic collision. In an inelastic collision, the objects are deformed afterwards, so they do not look the same after as they did before. Okay? An example would be a car accident, okay, where the cars end up dented. Another example would be if you drop some dishes, okay, and it breaks. If the dish breaks when it hits the ground, it's deformed now. It does not look the same as it did beforehand. Okay, that would be inelastic collisions. With inelastic collisions, kinetic energy is transformed into another type of energy. It is quote-unquote lost. Okay, so kinetic energy becomes another type of energy. All right, so we cannot use an equation that says that the kinetic energy before equals the kinetic energy afterwards because it is not going to be the same. However, momentum is conserved. Okay, so the total momentum beforehand is equal to the total momentum afterwards. The third type of collision is the perfectly inelastic collision. In this type of collision, the objects are going to combine or stick together after the collision. Okay? So for example, if you are shooting a bow and arrow into a target, the arrow will be stuck in the target afterwards. Okay? They're like one object afterwards, after the collision. All right? Another example would be if a football player catches a football. Okay? They're going to be one object after the collision, immediately following. Okay. Another example could be a meteorite hitting a planet. Okay. Meteorite hits the planet, it's going to stick to the planet. They're going to be one object afterwards. All right. In this type of collision, the maximum possible amount of kinetic energy is lost or transformed into other energies. Okay. So this is where you're losing the most. So you definitely cannot use that kinetic energy before equals kinetic energy after. Okay, because you're losing quite a bit. All right. However, momentum is conserved. So the one thing that we know about any of the types of collision is that momentum is conserved. So we can use that at any time. The total momentum before equals the total momentum afterwards. However, the only time that we can use kinetic energy is conserved is if the two objects separate afterwards and retain their original shape, because that makes them an elastic collision.